In the magnitude plot, at some point the slope is going to cross the x-axis. So this point is called as WGC, which is nothing but gain crossover frequency. And at this particular point you can see that the phase angle plot is crossing minus 180 degree. This point is known as WPC, and this WPC is called phase crossover frequency. Now based on this we are going to find out the phase margin and gain margin. Here in the magnitude plot this crosses 0 decibel line. So when this crosses 0 decibel line, this value is WGC, that is nothing but gain crossover frequency. At gain crossover frequency, find the magnitude of the polar plot, that is phase margin. And here you can see that the phase margin is positive as it is above the minus 180 degree line. Similarly, finding the value of WPC, that is when the phase angle plot crosses the minus 180 degree line, we get the value of WPC and then find out the magnitude in magnitude plot, and that value gives you the gain margin. And you can see that below the 0 decibel line the gain margin will be positive. So as both the values of phase margin and gain margin are positive, the system is stable. Here if you observe, the value of WPC is greater than the value of WGC. So this also gives the system stability. In this plot we can see that the magnitude plot crosses the 0 decibel line at this particular point, which is WGC, and then we find out the angle for the phase plot. We get phase margin with respect to minus 180 degree, and similarly the phase plot crosses the minus 180 degree line at this particular point, which is nothing but WPC, and you can see the magnitude, that is in decibel above x-axis, that is above 0 decibel, the value of gain margin is obtained. And here above the 0 decibel line the gain margin is negative, and below the minus 180 degree line the phase margin is negative. As both the values of gain margin and phase margin are negative, the system is going to be unstable. If any one of the value is negative also, the system is going to be unstable. Also, the other way to tell the system instability is when WGC value is higher than the WPC value. Now coming to the marginally stable system. So I can plot two graphs here, wherein this is the plot of magnitude and this is the phase angle plot. Okay. So you can see that at same point of x-axis both the values cross their 0 decibel and minus 180 degree. So that is why the value of WGC and WPC both will be equal. So this is called as marginally stable system. So you have the gain margin and phase margin value equal to 0 because there is no magnitude at this particular instant. So this is the summary of what we have studied. When the gain margin is positive, phase margin is positive, the system is stable, and when both the values are 0, system is marginally stable, and if one of the values is negative or both the values are negative, system is going to be unstable. Thank you for watching.